2026. Also wanted to welcome all of our online attendees from around the world. There's 15, 20 countries there. Welcome. Thank you very much for joining us. And so we're going to have a really useful discussion today, and we've got some really esteemed panelists which I'll introduce in a little bit, or perhaps they'll introduce themselves, do a better job than me. And so welcome to the panel. And so I'm going to talk a little bit about who we are. And so today I am representing the engineering. We'll just get that echo cut out. There we go. And so I'm representing the Engineering College of Technology and also our sister company or sister college in Australia, Engineering Institute of Technology. I will talk about them a little bit, not too long, because I know we've come here for the good stuff from our panelists. And so I'll talk a little bit about that. So what we're going to do today is I'll do an opening introduction to myself. My name is David. And then we will then move into the panel discussions for our online panelists, 3 of which are joining online. Thank you very much. And then 3 drove 4 hours all the way here to join us and to sit on the panel. So we're really grateful. Then we'll go into a group discussion together with some in-person and online attendees, questions and answers. And I hope there's really good ones, guys. Please put our panelists under a little bit of pressure with some tricky questions. We love it.
Oh, thanks for that.
Please do that. Thank you very much. And we'll do a final takeaway at the end of the session as well. We really want you all to go away with something to think about and something to actually put into action from the session. So again, thank you very much. I'm just going to quickly introduce myself and then move on to our wonderful panelists to talk a little bit about ourselves. But before we do that, I just also wanted to tell everybody who else is with us from the Engineering College of Technology. Our head office is about 5 minutes down the road as well, where our office is. We've got Sean in the back there, who works in student services and business development. We've got Claire there, who is an expert on the course and everything about the degrees that we do here in ECT. And then, of course, we've got Carolina, who's put all of this together and is in charge of the marketing here in the UK. So thank you very much. Online, we have some colleagues from around the world that will also be assisting us with the session. All right. So I'll quickly just tell you, we'll just get the slides up, Barry. And Barry's over there. He's in our South African office for our sister company, ERT. And he does quite a lot for us too. So he's going to share the slides for us, Barry.
Yes, just a second.
Here you go. We checked it earlier. It does work, guys. We'll just get it going in a second, which is brilliant. I'll tell you about myself anyway, because I hope I get it right as well. So my name is David Gardis, and I've been with ECT and ERT. So ECT was accredited as a higher education provider this year. So we're really excited about that. And our sister organization, Engineering Institute of Technology, it has been offering practical, high-quality, industry-focused engineering programs from professional certificate all the way to Doctor of Engineering for over 15 years. And Engineering College of Technology offers exactly the same focus for engineering degrees, okay? And the whole point about our programs is it's industry relevant, led by engineers and people that are actually in industry who will equip you to be employable. So my background in my first life was accounting, not good. No offense to any accountants if you're there. But I was fortunate enough to go into student recruitment and business development, first for a UK university called BPP, and then in my new home, Engineering Institute of Technology. I'm very passionate about student recruitment. I think it's vital to actually connect students with the right program, something that's going to add value to their lives. So many times my team of student recruitment people around the world, it's about 22 of them, I encourage them to tell students, don't study if it's not right for you, because it must be correct. It has to be relevant for you. So if it's not, we don't sell degrees, we don't sell courses. We link students up with the right course that will suit their progression. Am I right, Claire?
Definitely.
Absolutely. You should call me up on it if that wasn't the case. All right. So What I wanted to do is perhaps I'll ask Sue if you wouldn't mind introducing yourself and telling us a little bit about yourself.
Yeah, I'm Sue Armstrong. I am very recently just retired from academia, where I have spent 19 years teaching all aspects of electrical and electronic engineering, but being a real champion for automation and control. My industry background was as an automation engineer, so I spent 9 years in industry going around the world, doing everything from security systems at the Houses of Parliament to very small automated gates for Disneyland Paris to multi-million pound oil and gas petrochemical projects. I always felt like I wanted to teach because I didn't have a very easy route into academia to do my degree. So I always had it in the background that I really wanted to go back in and give something back to education. And I have taught from everything from level 2 at an FE college to being the program leader for the electrical and electronic and making sure that we had automation in there as a core, not just for the electrical engineers, but an appreciation for all the mechanical engineers as well. Because ultimately, if they're going to manufacturing, they need to know a little bit about manufacturing system.
Absolutely, and I think it's the world's changing, so we have to understand each discipline and be able to speak the same language. Adrian, if you wouldn't mind telling us a little bit about yourself.
Yeah, sure. My name is Adrian Morris. I am a production and quality engineer. I've worked extensively in industry for many years, but had a passion for teaching. So I told my wife at the time I was going for an 18-month contract with the university, which lasted 31 years. I didn't just teach. My main role was actually working with industry and delivering programs in industry, and then bringing back the knowledge that I gained from industry and plugging that into the academic programs. As a result, I finished my career at the University of Sunderland as program lead for the degree apprentices. So I was program lead for the degree apprenticeships for 2 years. Very challenging because it was, of course, the 2 years when Ofsted came as well. So it was fun.
Absolutely, I love that. The link between industry and academia. I think it's so important. Naturally, it's both ways. Yeah, and I think it's just enough.
Well, absolutely, it does, because we stopped calling it knowledge transfer and started calling it knowledge exchange.
Exchange.
Yeah,
absolutely,
because
brilliant.
it was a two-way thing.
Absolutely, thank you very much. Abdu, do you want to tell us a little bit about yourself and who you work for?
So my name is Abdu Shalan. I'm the Industrial Automation Course Leader at the ACT, recently started. My background is mechatronics engineering, and then engineering management, and then a doctorate in maintenance practices of automated systems, and basically how to keep the machines running and not to break down all the time, and in alignment with industry for technologies. I'm not going to say that I have 30-odd experience like Adrian, and that's going to be my age, really. But I did work on different projects, and I had this advantage of working in different sectors, on different projects related to automation and maintenance, oil and gas, food industry, textiles, different things. And I always felt that industry and industrial experience is a core element in order to be able to get into academia. So there has to be a link. You cannot really just go from one degree to another and be a teacher without having something that you can relate back to. Whatever you see in the book or read in the book or see on a video on YouTube or whatever it is, does not really reflect what the actual industry or SMEs, small and medium enterprises that makes the most of the industry is really. Mm-hmm. So I did work with Adrian on many projects, and Gary, who we will hear from soon, and different people, and really got the chance to get to industry and to get to the real core pillars of industry and see what it needs and how can we really benefit from their experience and how can we transfer our knowledges and our academic expertise and research to them as well. They teach many modules, multiple modules, maintenance, automations across different degrees, supervised PhD students at my previous institute, and now leading the industrial automation program at the ECT.
Absolutely. So our very own Abdu here at ECT. We've also, Carolina's going to make sure that I'm on time, but I like to be a little bit cheeky sometimes and extend a bit. I just wanted to also just get an introduction for Dr. Gary Thompson. If you can tell us a little bit about yourself, please.
Hi guys, how are you doing? Good to see you, Adrian. Abdu, hope you're all right.
Dr. Gary Thompson, going to get you on here. We're going to figure the tech out and get you on here. There we go. We can't hear you, but I can see you. I hope you're feeling energetic.
Yeah, the mic's on, so not sure why it's not picking up.
While we actually just work out the sound there, I'm actually going to prod Associate Professor Hamid Merabi actually just to take that while we look at your sound there. If you wouldn't mind just quickly telling us about yourself.
Yes, hello everyone. I'm Hamid Merabi. I'm associate professor.
We have a few couple gremlins perhaps that are in the midst there, but it's okay. We apologize. We can't hear you. Here we go. Wonderful. Great. I wonder. That's brilliant. Thank you. Yes, please go ahead.
Can you hear me now? Yeah.
Yes.
Yeah, I'm Hamid Mehrabi. I'm associate professor at Sunderland University, Faculty of Business and Technology, working on materials and manufacturing, been there for as long as Adrian. And yeah, I've been teaching and doing research on manufacturing processes like casting, welding, and heat treatment and additive manufacturing. And it's a pleasure working with Sue, Adrian, and Abdu, and Gary Thompson for last 6-7 years. That's me.
Brilliant. Thank you very much. Short and sweet. I'll describe myself at times, but it might not be accurate. And then we also have Richard Scott, who does a bit of lecturing for our sister company as well, knows ECT and ERT fairly well. Richard, are you there?
Yeah, I'm here. Can you hear me okay?
So joining so early. Yes, we can.
Yeah, good. Hi. Hello, everybody. Yeah, I'll just give you a little bit about myself. I've been in industry now since I left school in 1966. So I'm a real baby boomer generation type automation engineer. I started off as an instrument mechanic for North Thames Gas Board in East London, and then went on completion of the apprenticeship, did a couple of years as an indentured apprentice, and then moved on to work in the drawing office for Bechtel's in West London on BP projects in Abu Dhabi. And from there on, I went on to work for various other EPC contractors, as starting off as a designer or draftsman, as you might call them, and then worked my way slowly into engineering positions. And more recently, I've been working on overseas oil and gas projects out in Kazakhstan, Norway, here, there, and everywhere, basically. Oil and gas projects mostly, and acting in different roles in on those projects. Mostly more recently as in client teams. So basically we've been overseeing the actions of EPC contractors working on those projects. So monitoring the design, approving the design, and making sure the contractor is fed with all the relevant information, and then approving the design and monitoring process and reporting to the client management teams on the project and dealing with any ongoing issues. That's putting it very succinctly. So yeah,
a very good skill as well to summarize all of your experience so succinctly. Thank you very much. I wanted to just try Gary again, if you can, we can hear you, put it that way.
Yeah, can you hear us okay? Wonderful.
Now? Absolutely clearly. Thank you very much, Gary.
No bother at all. Right. So, as it says on the wall, I am an old school engineer, a bit like Richard. I left
I know, mate.
school and went straight into engineering. However, I actually started on the machines when I was 9 and 10-year-old because my brothers were old school engineers as well. I've worked across the globe. I've worked in 73, 74 countries like that now. Worked in every sector going, aerospace, production, food industry, you name it, I've been involved. But when it comes down to it, I'm an old school toolmaker. That's what I am. So I build machines from the ground up. We do the design. We work on the full projects. We then get them built to use the full latest automation techniques, get them installed, get them running, and make a difference for the clients. So that's me in a nutshell, mate.
Thank you. Thank you very much. And we're looking forward to hearing insights from all of our panelists and to those online as well. Remember, keep the questions piled up. We've got a Q&A session at the end now. I am going to just quickly tell you about the courses that the Engineering Institute of Technology and our UK, the wonderful Engineering College of Technology offers, so we can see what they are. Okay. So we're going to go through to just a couple of slides, and I promise to keep it short because we're here for the panelists, and I'm really excited to actually hear what you have for us. So something about Engineering College of Technology and Engineering Institute of Technology. They're sisters, they're family. And we want to offer UK recognized degrees. We're offering them to students around the world. And so in the family, we have about 5,000 online students from 140 countries in the greater group of the family. Something about the courses, it's kind of in the name, Engineering Institute of Technology, Engineering College of Technology. That's all we do. We love engineering, not interested in other courses. And the programs, as I mentioned, are industry focused, industry led. We want it to be relevant. Otherwise, it's just an academic program, right? So we want it to be applicable for engineers. You'll see here that the programs ECT offers are UK recognized programs, a very rigorous process that you want us to go through. And Engineering Institute of Technology courses are also globally recognized under various engineering accords. Okay. We use a lot of technology and cutting edge tools. Now you might say an online program because all of our programs are delivered online to where you are in the world. How do we stay connected? Well, we use technology. We embrace AI technology platforms. And so we use live webinars to make sure that you're connected to people like Abdu over there who lectures and our lectures around the world. You're in class, you're attending these, you're actually live and you're connected. It's not a place somewhere out in the, who do I call? What do I do if I'm a little bit behind? We've got all the support in place for you to actually ensure that you are connected. So we use technology for that. Personalized student support. I think everybody here has had to call the bank or an insurance company before in their lives because something went wrong. Am I right? People online as well, wherever you are. So can you imagine calling the bank and you're saying, guys, some debit's gone off, what do I do? You're bouncing around for 3 hours, frustrated because you don't know who to talk to or where to go, right? Well, the parallel can be actually seen in online education, I believe. With Engineering Institute of Technology, you have a learning support officer that is attached to your course. Engineering College of Technology, there's a learning support officer. So someone that is dedicated in your module, per module, to actually track your academic progress. Make sure that you're attending, doing your sessions, make sure that you are progressing. So that support is vital, but also for things like your labs and your platforms, because some of them can be a bit complicated, right? And so you have someone in all areas of your program that will support you. And that is extremely vital because you have to be engaged when you're studying this program online. Okay. And then there are students and faculty based around the world. And so you'll gain insights from students around the world and also academic people around the world. And so I think that's really valuable, what's happening in other places. And I mentioned that, I want to talk about that because I kind of mentioned it's innovative and we use technology. And so I just wanted to close off on the next slide. And if we can just move to the next slide, Barry. Just to remember, we're here talking about Engineering College of Technology, okay? And then also the Australian provider. I just wanted to make sure that if we're unsure about, there are two separate entities, ECT registered in the UK, registered in Australia. Just make sure that if you have any questions, about the differences. We are looking at Engineering College of Technology for the UK courses, doing our research. We can ask us some questions. Okay, the links are there. And then the last but not least, the next slide, just a little snapshot of our Engineering College of Technology courses. What do we offer? What degrees do we have? And so we offer 2 Bachelor of Engineering Honours degrees. Okay, one is in Industrial Automation, and I'm sure my colleagues here would really like to would like that. Bachelor of Engineering Honours in Electrical Engineering, and then a Master of Science in Industrial Automation and Instrumentation Control, and naturally Master of Science in Power Systems Analysis and Renewable Integration. So those are our 4 UK recognised programs. The bachelor course can be done online between 3 and 6 years, so full-time or part-time, okay? And the master course can be done, it's a 1-year master. It can be done in 1 or 2 years. The bachelor course is done in a semester format, and the master course in a trimester format as well. Okay. I think we just have one more, and then we're going to get to the good stuff and all my people online. I mentioned that it's online. Well, what does that mean for labs? Is it really practical? What does it all mean? So we use a combination of remote and virtual laboratories, and there's a wide range of them. So students can use our platform, Electromeet, and book a lab, and that can be a remote lab, so a real piece of equipment in the UK, in South Africa, in Australia, and different locations. They can also use our virtual laboratories. So we have a range of simulated labs as well. So you can do a lab at 12 o'clock at night if that suits your schedule, right? Because we're all working people, and we want to upskill ourselves, or perhaps we're school leavers over there as well. So we cater for pretty much everybody. And it's really cool because you can't blow up a virtual lab, right? You don't have to put fuel in it. So that's pretty cool. You can't shock yourself, right? Well, maybe sometimes it's more shock if you don't make the mistake again, guys. Right? But we use technology to ensure that you have that practical element, because that's what we tell you we'll give you. That's what we're going to give you. I mentioned we do physical. I've got a really awesome in Perth production line, and then students log in, do the coding, make sure fix the faults, and it's a mock production line from about there to there. That's just one of them. It's pretty cool. And you'll see that moving at night sometimes can give you a bit of a fright if you don't know what it is. It's complemented by workshops. So students that are studying online are able to go to South Africa to do the practice, actual physical workshops. Also in the UK, we're building up the workshops, and also in Australia. So there's different options for you to do the actual workshops. Right. And just remember, I talked about the labs. You'll log in and you'll use the software there. You don't download it. You don't have to buy a license. You just log in and use those labs in real time. So reduce the stress for our students. I think that's really important. Okay, now, enough of me. I want to hear from our panelists. And so we're going to talk about, basically the panel today is going to explore how automation, sustainability, education, and engineering technologies are reshaping engineering careers and industry needs. We'll also provide practical insights for engineering professionals, technicians, technologists, engineers, all across the levels, educators and students looking to stay ahead of change. And we know that's going to happen and also rapidly in recent times. Right. It's a bit of a mouthful, right? But now I wanted to hand over to the panelists. We want to have a conversation. And so we've got a few questions that I actually might start. I hope you don't mind, Dr. Gary Thompson. I thought I'd open with you, and I wanted to say you've worked globally and are passionate about revitalizing really important industry, UK manufacturing. What practical steps can we take to rebuild a strong, robust and sustainable manufacturing base in the UK?
It's a difficult one, really, because it actually applies not only to the UK, but to every country across the globe. If the UK in specific, we need to give people a reason to manufacture here. We'll never compete with what we're doing with companies in the Far East because it's a cost-based scenario. What we need to do is actually give them a reason to believe that we can actually do what we say on the tin and actually make things. years ago, I was in a meeting and I actually said something which rattled people's cages, and both Abdu and Adrian and Hamid know what I'm like on this one, because I say it as I say, call a spade a spade. And I said, we do not, as engineers, want to become the call centre of Europe. We don't want to then signpost people to other people to make things. What we need to do is actually, as I say, give people a reason to be able to make things here. We need to educate the people, and it's ideal what the ECT's doing, where it's actually giving people an opportunity to see what they can learn and what they can become. I'm like the guys and the girls are very passionate about being engineers and bringing the next generation through. However, the issue I'm finding with some of the local centres up here in the northeast is the people who are teaching engineering aren't actually engineers, and they're missing the basics out. They're missing what we need to do. If we can actually change that supply line, then we can actually educate them literally from the grassroots level. And I'm talking primary school level. I know a lot of people go and talk to young people in education at 11, 12-year-old and say, oh, what are you going to be when you leave school? That's too late. That is too late. I mean, if we can encourage engineering, we've just completed a STEM project with 9 and 10-year-olds, and it was absolutely brilliant. And we introduced them to 3D printing, which I had a chat with Hamid a while ago about. We introduced them to engineering techniques, to how things went together, to manufacturing. And we did it over an 8-week program, and those kids loved it. And the actual teachers used to come and say to me, I've learned more in those 8 weeks, Gary, than I did in my training before I became a teacher. So if we can take like a reset button, push that button, take a step back, and use some of the old skill sets that we learned many, many years ago. And I mean, I listened quite intensely to what Richard was saying. I mean, Richard probably served his time when Feet and Inches were around, and that was me. I actually worked in Feet and Inches, and we've got young guys that we are working with from 2 of the local colleges who we're going to actually encourage them to go to university and do an engineering degree. They're coming to us because we're actually showing them a different way of becoming an engineer. It's not directly through the academic route. I left school, became a toolie, did a 5-year apprenticeship, worked right the way up through the ranks, and I didn't go to university till I was 36. So, you know, it's that's the way I would do it. That's the way I would say UK manufacturing needs to reset itself and actually give the people a reason to make stuff here. Hope that answers that question.
Comprehensively, and I just had one more. I was wondering in terms of costs, like what would you, how would that play a factor into competing with other areas or other countries?
Yeah, well, what we need to do as well is learn to design for manufacture. There's a lot of things that you can do on a computer, and the computer doesn't have the common sense to say you can't make that. And I get so many people coming to talk to me with products that have been designed by, and it's no disrespect to the designers on that side, but they've made it look really pretty, but you can't manufacture it. You can't tool up for it. So they're adding cost onto the job. And there was a time when I was working with Adrian and Abdu up at the Sunderland University. We had a client who come in, and that project was going to cost £200,000 for the tooling. Once we actually reviewed it and did a redesign, the tooling saved about £160,000. And it being designed by should we say, a design house in inverted commas, but those designers had no manufacturing or production experience. So this is the issue that we face. To get the cost down, we've got to design it for manufacturing, design it that we can use, and as well use technology. A lot of the machines I build, we're actually including IoT automation where we can off the shelf. And if we can get parts that are off the shelf, 24-hour next day delivery, we know going forward from a preventative maintenance point of view, we know through the IoT side what's going to go first. So that's another area.
Absolutely, and I really enjoy the passion that you speak with as well. And you definitely mean everything you're saying there. So thank you very much, Gary. And I've got a question for Adrian, actually. We're talking about manufacturing, and you've worked on hydrogen and hybrid fuel systems. And so I just wanted to know, what opportunities do these technologies present for engineers in manufacturing and also in transport?
Hydrogen in transport is an interesting one. I used to run the low carbon vehicle program at the university, and we looked at putting fuel cells into vehicles, and that has some tremendous advantages because a 5 kilowatt fuel cell will produce 5 kilowatts of electrical energy, 5 kilowatts of heat, which batteries don't do. But they're hideously expensive. They're very easy to kill. You can poison them very, very quickly. And they're also quite delicate. So I think fuel cells in transport still a little way away. Fuel using hydrogen as a mixed fuel with petrol or diesel, though, is a very real possibility. And a bit like Gary, I like to rise to a challenge. And we were told by some very clever people that there's no way you could make a car to run on a mixed hydrogen and petrol fuel flow for less than £250,000. Well, we only had £17,000. So we sat down and we worked out exactly how we were going to do it, and we did it. And it ran beautifully. It ran really nicely. We couldn't have done it without Nissan giving us a car, but there you go. But we tested it. The only problem with hydrogen as a fuel for transport is hydrogen burns at a very high temperature. And the air we're breathing is about 80% nitrogen. And it's high enough to split that nitrogen molecule into single monatomic N, which will eat everything it can get to, but it produces a lot of nitrogen oxides. So you have to find a way to actually cool that temperature down. But fantastic way of keeping down CO, CO2, particulates, absolutely brilliant. So it would be, I think, a really interesting way, or if you're interested in transport, of getting into that sort of field. Hydrogen fuel cells, stationary applications, fantastic. Hydrogen's a great fuel. It's around, there's an awful lot of it. We can produce it relatively cheaply. As long as it doesn't have to be super clean, then Bob's your uncle. So it's a good fuel. It's something that we actually have used a lot in the past. Coal gases was largely hydrogen. So this is something that we know a lot about. You've got to be careful with it. It doesn't like steel. It will embrittle it. So it has some fascinating challenges for people. But I think it's a super clean fuel, and it's certainly something to be getting involved in.
I talk about cost a lot because that's obviously a very important part of business, naturally, low cost base. And so what was the biggest challenge in reducing 250K to 17? Or what would you, in a nutshell, explain how you did that?
I think using off-the-shelf technologies that had already been developed and adapting those technologies. So what we actually did was we took a liquid natural gas system and we adapted it to run with hydrogen. We then used some fairly clever sort of automation within that to actually switch the hydrogen on and off when we needed it. And that sort of thing kept the cost down dramatically.
Wonderful. So something practical and simplifying, basically.
Yeah, it was just, we like a challenge. And for those who don't know Sunderland University, there's a reason why you don't know it, because we're not Oxford and we're not Cambridge and we're not Imperial. So we're not swimming in money. But when people came to us and threw out a challenge, we do like to rise to a challenge. We're practical engineers, and that's what drew me to the degree apprenticeship as well, which is just part of what Gary was talking about, which is how we make engineering a really interesting subject. And it's giving people the basic theory and then allowing them to put that into practice so that they understand it better.
Wonderful. Thank you very much. And I want to go back to our online panelists, and I wanted to we touch base on some of the introductions and also some of the things I spoke about. Associate Professor Ravi, if you wouldn't mind just telling us a little bit about something that's really important, academia and industry work more closely together to prepare people for rapidly evolving technologies and job demands. And jobs are, I mean, as an engineer, obviously it's a lifelong learning journey, otherwise you just stagnate. But how can we give some practical advice to some of the people online around the world and also here?
Well, thank you for asking the question, but a difficult question though. But we're already doing this. We're already trying to collaborate with various industries, all universities, especially in UK. The main advantage of collaboration is learning from each other, learning from industry and industry vice versa from the academia. And with communication, with collaboration, there is so much information we can both benefit. And I learned this through many years of work. When I was doing working as a lecturer, it was okay. It was I was learning theory, but when I was working with industry and people from industry, I was learning so much from the industry, from those people, especially. I mean, a very good example was SAM project, as Adrian was mentioned and Gary mentioned. SAM project for the last 5-6 years, I worked from in Sunderland University. SAM, Sustainable Advanced Manufacturing, was we were supporting SMEs in the Northeast through communicating with companies, dealing with their problems. We could see, and dealing with problems at the same time, working with colleagues like engineers, good engineers like Gary and Adrian and Sue and the rest of the team. I learned, personally, I learned so much from in their background and industrial experience, and working with the industries. There was so much that I could learn that I could pass on to my students in my lectures. So, but this communication should be continuous, should be through apprentices. I will learn so much from apprentices. There is a very good communication between lecturers and apprentices. Lecturers learn from apprentices and vice versa through the communication. Running the projects, real projects from the companies, with the support, with the supervising the projects from both ends, from industry and the university. So through internships, placements, there are so many opportunities with placements and internships, but it has to be on a continuous basis, not on and off. If we carry on doing this collaboration, communication, it's win-win situation for both ends, for both academia and industry, and especially for students that they can catch up and they can be updated with the real situation in industry, and at the same time develop a very good theoretical background and base. So as I said, it's all collaboration through working with people from industry and academia at all times on a regular basis, continuously. That's all I can suggest.
I couldn't agree with you more, and I think probably everyone here agrees with that. And do you find do you come across people, because you would meet students from all different areas in the UK and perhaps abroad? Do you sometimes see a student, and I get this a lot when I travel, certainly in Australia and UK and different parts of the world, where the students are saying, I've got to relearn, I've just qualified with a master's, and what I'm seeing on site, whether it's a power station or whatever, is not what I've seen in my textbook, and I'm a bit lost. Do you come across that quite a lot, and it's quite distressing, I believe?
Yeah, well, if I get the questions right, I think we had a very good examples here. Students who actually, I work on project base. I focus on the projects so much for the students. to when they design their project, final year projects or second year projects, we try to encourage them to find their jobs there and then. Look for the job opportunities. Based on job opportunities, look for design your project. And this works, and that helps them to develop, understand where they end up, and it helps them to find jobs much easier based on what they are developing during the second year and third year. And we have what you just said. Yes, the opportunity is to be able to do the practical work, get involved with the companies who are doing similar jobs to their projects, and that helps them to develop, and they move faster. They can be updated, and they can actually, well, I call it fly. They can fly after their degree. And I've got examples that I can tell you this, because I had some students, Chris, another guy from Nigeria, when they finished their projects based on their practical work they did with the companies, they were all over the place. Did I answer the question?
Yes, and there's something I just wanted to add to that. I think also, apart from the practical experience, because we cater for students, school leavers, and also people already in industry with experience. I think in terms of the programs, it's so important that it's relevant. What people are teaching is actually latest technologies, latest processes that you'll find on site. That's something I think, we definitely make sure that we do. I think it's really important. And thank you very much for that comprehensive answer. We really appreciate it. You mentioned there's something else that's sort of very important in education. And so I'm going to ask you a question. And it's something that we talk about a lot in terms of, there you are, Sue, there we go. Based on your work with industry and education, what technical and then also soft skills, and I think that's obviously sometimes quite slept on, the soft skills, things like communication, writing, technical writing, and all that type of thing. What will be most in demand, technical and soft skills in a combination for engineering professionals entering work next year or at any time?
From the technical side, there's always, and there always has been, the programmable logic controllers, the code, and the computer side of things, which is always evolving. And it's interesting, but if you teach a certain package on the first year of a degree, that person won't be graduating for at least another 2 years, 3 years. And packages, the computer software changes so quickly. So one of the soft skills is to be continually self-developing. You can't keep everyone up to date all of the time, but what you can do is give them the confidence to go out there and find out and to do their own upskilling. I think engineers now need more technical skills with things like data visualization, with getting massive amounts of data, so data analysis, which is sort of verging on the computer side of things as well. But it's a narrow line between the computer side and the automation side. The other technical skill I would say is, yes, technology is brilliant and we all want the latest technology in a system, but to stop and ask, does it really need it? In industry, I've seen lots of instances, for example, when GPS systems were first coming out for machines, brilliant, all the big names, Siemens and that, you can buy this GPS system for your automated machine, but that machine is going to be sat in concrete and never ever move for the whole of its life. Why would you want to know its position? It's not something somebody can put in their pocket. It's just because the customer likes the thing, oh, it's new, I'll have it. So yeah, it's to question things like that. If they still want it when you explain it's useless, then fair enough. To try and rip a whole production line out because they've changed the shape of the furniture that they're making, and the machine won't take it, when all you have to do is literally pick that chest of drawers up and turn it upside down and it will go on the production line. But sometimes your boss isn't happy that you've said that £30,000 project's no more. So yeah, it's just to stand up and say, the confidence to do that. And one of the things I find that graduates have always said when they're coming to the end of the degree is, I don't feel ready. I don't know enough to be an automation engineer, a power systems engineer or whatever. And because you get the grounding, it's to go out and you find out about what you want to do, and different companies do things differently. Ask questions. Don't take no for an answer. If you don't get the right, if you don't find out, go to someone else and keep going, keep researching, keep finding out. And the other big soft skill that a lot of graduates don't realise is you are going to have to work with people. They think because they like science and maths that they are going to sit and do science and maths all day, every day. But no, you have to work with people. So to try and involve group work as well, especially from equality, diversity and inclusion point of view. Not every graduate has come through from the A-level route. Some might be mature, some might have, you know, done an access course, have non-traditional lifestyle as well. And we get a lot of new diverse people doing engineering jobs now, which is somebody who used to have a lot of sarcasm in that lesson. You have to learn to know this is how we do things now, and we work together as a team. And the diversity does give you amazing solutions to some problems, because you get a lot of different views that the traditional scientist wouldn't come up with.
There's a lot of things there I can resonate with what you said there, and I think my father's a retired high voltage electrical engineer, so he's worked with GC and Alstom and all that type of thing, and so I grew up, you know, sort of seeing how he does things, and so like basic things like interacting with people wasn't his strong point, but a brilliant engineer, so he got the job done. But then it's changed so much, and so we've got STEM, but what Steve, the ECT founder, talks about all the time, that there's an extra little E missing there. So you can add a lot of different letters. So it could be STEAM, because there's entrepreneurship involved there, but not business only. You have to understand costs. You have to speak to different teams, understand how their needs filter into your area. So project management, for instance, is probably very important. Do understand what the mechanical engineers are saying to the design engineers or the automation engineers?
Yeah.
How does it filter in? And also, is it going to be cost effective? Well, I'm not an accountant, but I need to kind of know if it's going to be effective or not. And we're talking about cost again. The world's changed as well. So we have different people from different backgrounds. So at our institution as well, we have people from all walks of life, people with work experience over a long period of time that enter. And I think support is very important when you're studying too. But and so if I look at my father, if he comes into the workplace now as a fresh engineer, completely different. And so we embrace that. We have to. Thank you very much for that. We really appreciate it. And we got to, I'm just checking with Carolina here now, going over a little bit over time. So we've got 2 more questions and then we'll go into a group discussion. Richard, if you don't mind, I've got it here. Now we're talking about artificial intelligence. I hope we're not too fatigued with the word artificial intelligence, but it's part of our lives, right? It's not going anywhere. We could say it's almost intelligent, but you know, it's there and we embrace it and we want people to use it in a controlled way. But with AI becoming more integrated into control systems, will this reduce the demand for human expertise in engineering? What is AI? What do we simply call it? Or would it shift the type of expertise needed?
Well, we're going to use digital technology generally in design and engineering, basically to unburden human beings from labour in intensive tasks, in labour intensive tasks. So when it comes to design, engineering data sheets for sensors and actuators on a process, for instance, or for engineering a control system. You know, we're going to use that. I don't know that artificial intelligence is going to really bring too much to the table when it relates to an automation system. When you're talking about the OT level of automation system, perhaps in the higher levels, the IT systems, because looking at the integration projects that are coming to the fore now with Industry 4, it may have a greater bearing on what we're doing now, but I can see it only having limited impact on our ability to design and deliver automation projects in the near future. I don't know if that's enough of an answer to you. I mean, it can be integrated. Industry 4 basically brings real-time control into the cloud, into cloud-based applications, where you may more use artificial intelligence. But we are really concentrating to a fairly large extent on traditional SCADA systems when we're designing and engineering automation solutions. The cloud-based applications bring on additional functionality which can be integrated into the upper levels of your organization, if you understand what I mean.
Absolutely, and so that's a very high level now, but it's understandable to me, which is really good. And so I mean, if you even look at artificial intelligence, if you wanted it to design a room that feels, a kitchen layout that feels good to you, it can't do that, right? They can just do exactly what you prompt it to do. And you have to check it, right? You have to, if you're using it for other things, you basically have to make sure you have to check it. And I had an interesting stat just about AI in general, about the amount of content that's on the internet that is either processed or generated by AI. And can't remember the exact percentage, but I think it's over 90% of information that's available on the internet is either produced or processed through artificial intelligence. And I think it'll be close to 99% soon. So we need humans to produce information and create more things. I think they'll never fully replace us. Last but not least, Abdu, thank you very much for your patience, and I'm sure I owe you a copy after this for that. In terms of Industry 4.0 and automation, how would Industry 4.0 and automation redefine engineering roles in the next 5 years?
In the next 5 years, well...
Oh, sorry, Richard. I mean, it's a question for Abdu. Apologies. Thank you very much. We're going to have some more questions in a minute. Thank you, sir.
Okay.
Thanks.
So the way I can see it's heading is it's all about changing how people are carrying out their jobs, really. So we're shifting from traditional mechanical engineering, electrical engineering, towards more of an integrating engineer that knows different sets of skills from different systems. This might have sounded strange when I got my first degree, the mechatronics, and the whole idea of it was just we're having pieces of knowledges from different schools, really, some mechanical, some electrical, some computer science, some control. So what do I actually know, and where is my expertise? But this is the future of engineers, really. You have to know something about everything. And it's all about, do I understand what's control? Do I understand what is AI from Industry 4 elements, and how can it help me to analyze data? We've seen the impact of this, especially happened with COVID, when everything went into fulfillment centers and order things online. How can we manage this? How can different companies started to move from having a warehouse and a shop towards only having fulfillment center like Amazon and how Amazon works, and how can they deliver single products or single orders to different customers? This needs data analysis. You need to know what are the trends. I cannot really store everything possible and the seasonal products all the time at my warehouse. I have to use everything. This is where AI is coming across. Control elements and robotics. Now we have cobots. The robot is transformed from being that beast in a cage towards a device that can work around you in a factory if you are an operator or if you are an assembly operator or whatever you do. So you can work around robots now. It's cobots. The terminology did change. How do you deal with this? How do you work around it and use it? So skills-wise, it's all about moving away from repetitive tasks. I'm on a production line doing the same job every day, every night for the rest of my life, towards having different sets of knowledge and know how can I get different technologies together and look at the big picture and how can I be more professional in what I do. And maintenance, where I know more about from my PhD things, how can we use data analysis? How can we use sensors to predict when the machines are going to break down? Breakdowns and the machine failures is the most annoying cost to industry. If a factory main asset, main machine broke down for a day, let's say to relate it a little bit to the cars manufacturing sector. So a car factory makes a car every 30 seconds. If one machine out of these hundreds of machines working together broke down for an hour, so how many cars you lost really in production out of this for every 30 seconds? So you can see that how can it help maintenance? How can it optimize maintenance planning? And how can we make sure these machines will never break down? So different sets of technologies and know many things and know different skills rather than being just that repetitive, isolated person that doesn't want to see anything out of what they are specialized at. That's what I would say.
Absolutely. And you've actually just sparked a memory of mine when I had a conversation with one of our students, and he traveled quite a far distance to come to an event like this because his employer said, no, you go, I'll give you the time off. You go, I'll pay. And he was talking to us about how he saved his company a lot of money. And so I won't take you through the whole process, but basically when he started working at the plant, everything was manual. So time is money, lost production, lost time. To when to the end, he actually started even ensuring that the amount of water the cleaners are using, it's monitored and automated. And then all throughout the plant, he implemented instrumentation and monitoring for everything. And so his employer was so happy about that because it was a massive cost saving through what he learned through us. And I think that was brilliant. I love hearing stories like that. Thanks very much. And over time, then I'm just checking to see if Carolina's giving me the there. But thank you very much, everybody. And so what we'll do now is we just want to go into a quick group discussion. So this will be a discussion with our panelists, and some if perhaps Prof. Marabi, Richard, Gary, if you also wanted to take the question, and our panelists here, maybe just pop your hand up if you wanted to add a comment to that. So we'll take maybe 2 points, and then we'll have a discussion around that. Then we'll go to questions and answers for our wonderful, amazing online attendees and also everybody here. And so in terms of, this is a general question, and I wanted to know what our panel thinks. And this could be questions that we've asked one individual, but there could be some insights that we have from different areas and different sets of expertise. And so I wanted to say, what skills or mindsets does everybody believe are essential for engineers at any stage to stay adaptable in a training industry? We spoke about that at length with some of the panelists. I just wanted to know if there are any additional insights in that area. We've got Adrian, and then if any of our online panelists want to add to that, I think if we put our hand up, it actually comes in order, which is quite handy.
Well, I would say the key thing is curiosity. Curiosity. Why does this? Why is it this? Why? What do I need to know to solve this problem? And how do I solve this problem? So, for instance, we were talking about AI then. How are we going to make use of AI and stuff like that? One of the key things that I did before I retired was looking at data analysis of machine tool energy consumption, which sounds simple, but it isn't, because every single part that a machine tool makes is different. And so the signatures are different. They're sort of similar, a bit like your own signature. It's recognizable, but it's different. Yeah, and so AI is able to sort of then look at that and pick those patterns out. And it takes a lot of, I think it was Richard who said, it takes a lot of the repetitive sort of hard graft of crunching numbers away from humans, and we give it to someone, the AI, that does it really well. Yeah, so curiosity, how do we harness this technology? How do we make it work for us rather than us working for it? Because that's really the wrong way around. we need to sort of make use of this.
Absolutely, and I think it can be intimidating, and I think so you were talking about that. It's intimidating to actually to face all these new things. But as we all know, the age-old saying, if you're scared of something, just do it scared. And then what's the worst that could happen, right? I think Prof. Marabi wanted to add to that comment.
Yeah, Adrian took the best word for it, curiosity. We are very good. I think I can come up with adaptability. Adaptability, it's very important because, yes, mechanical engineers, electrical engineers, manufacturing, all sorts of basic engineers are, they should be there. It's just they have to be adaptable. People, students, engineers, they have to be adaptable. And I can see, again, I've practices from Adrian himself, Gary Thompson. So these are practical engineers who actually adaptable engineers. They, as I said, they could deal with any problem at any time based on their original education. They actually practice this in some project, and adaptability is very important, and that's why curiosity killed the cat. But the whole idea is that curiosity causes that I came all the way to Sunderland to learn about additive manufacturing, and I learned so much about 3D printing additive manufacturing from STEM project from some of my colleagues, which again I could use it for my teaching, for my lectures, and I think the students can benefit, engineers can benefit as well from. That was my point.
Wonderful. Thank you very much. And just to close off on that question before we go to the last one, Richard, you got something to add for us?
Yeah, just something I think might be relevant here. You know, what might be sparking students' interest in asking questions about the role and the responsibilities they're likely to encounter as automation practitioners. There are a number of different roles that you know can all be collectively defined as automation engineer. I mean, you got things like product development engineer, standards engineer, vendor systems engineers, systems integrators, engineering contractor or consultant. You can have like an asset operator, SCADA engineer, you know, within operations and management, operations and project operations management environment. And you know, there are other roles like that. So they're going to be coming at it from various angles. And I think it's important to give students a good overview of automation, how it's applied, and the different roles and responsibilities that belong to different functions, looking at over the whole spectrum of operations and maintenance, and also project management as well. It brings so much under that one banner of automation engineer. So I think, you know, it's a good thing to make students aware of the structure of an organisation, the structure of a project team, and the structure of an operations and management team. It's just that might drive their intrigue about certain functions or certain things that they may need to study within their degree or within their apprenticeship. It's just going to spark off some enthusiasm for the job that they're likely to do.
Absolutely, Richard. I think that's a really important point to make, not only for engineering, but why the what, the for whom, so you can actually sort of see where your value lies and what value you can add in the grander scheme of things. I think that's a very valuable point there. We're going to move on to one last question. That's okay, Carolina. We're going to do one last question. We have spoken about this again, but I really want our attendees online, everybody here, just to get as much information as they can in terms of how to stay job ready. What am I facing? What do I need to do? So just one more point on industry is that in an industry that's always evolving, is there any other advice you'd give to technicians, technologists, engineers, anybody else? If you're just starting out, or if you're actually halfway through a career, transitioning to another job in a different role, any last words in terms of how to stay resilient, not to give up, and how to stay job ready? Anybody? We've got Sue that's thankfully put hand up, and then Prof. Narabi, Richard, and Gary. Thank you very much. Just a couple of words on how we can do that?
You definitely need resilience. I remember my first job as a project engineer, and the first project that threw us was a mechanical project, but I'm an electrical engineer. And being a project engineer for small and medium-sized enterprises, you tend to be let go at the end of big projects. And I know certainly in the Northeast, it was that every automation engineer knew each other because we'd all work together at one point for one project, and you get moved around the country and things. But it's just to remember that, if you hit a stumbling block, you've got to find out what you need to get to the next stage. So if the first time I got made redundant, it was a shock, but I thought, right, I don't want to work for the food industry anymore. I'm sick of coming home from a factory smelling of beefy crisps. I want to go off to the oil and gas industry. So I've pushed myself that way and got a job with a company and done some projects that way. And it's just, think of it as an opportunity rather than a knock when you get one of them instances. And that can be not just being made redundant, it could be finishing one project and starting another. If it is so different, you can feel a bit overwhelmed by it, but just treat it as an opportunity to learn something more. Again, it's the lifelong learning and pushing yourself.
Very, very practical, but probably the most important thing is just stay focused, one foot in front of the other, look for a way to solve a problem like engineers do, basically, and for your own self. We've got the first, Richard, a couple of words on that? So I mute you there, Richard. You can unmute yourself.
With this Teams, hold on a minute. Yeah.
Here we go. We got you.
Yeah.
A couple of words from you, Richard.
All I would say to any student starting out or coming out their time, let's say, is strive to be aware of the changing needs in industry. We've already discussed things like the soft skills, etc., technical writing, continuous development, continuous improvement, and teamwork. These are all essential parts. You've got to be aware of industry trends and the automation needs for these, for each sector. And, just basically keep your finger on the pulse. Membership of a professional institution like the Institute of Measurement and Control works wonders for people, if you ask me. I receive regular publications for them that tell us about what's going on in the world. So all these kind of things, it's really, you make your own future in this world. The more effort you put into it, the more you'll get out of it. It's as simple as that.
Absolutely, and very, very wise words. And I wondered if Gary could add to that as well, sir. Thank you, Richard.
I would always say one thing: the only person that holds you back is yourself. So when you are in a position to wanting to move forward, and like Sue says, in the Northeast, where you can be flat out one week and then sitting on your backside the next week because the job's changed. You need to keep, like Richard says, keep your finger on the pulse. What I would do is make sure you are connected, you're networked. You know what's going on in the background in other jobs, and as I say, jobs change all the time, and you need to be aware of those changes coming through. If you can stay ahead of the curve, like working, as Richard says, with different organisations and membership establishments, you know what the next stage of technology is coming through. One of the projects we do, and it's ideal what Adrian said earlier about biofuels. We're actually working on a biofuel project now, and that's something out of my remit. But for the last 3 weeks, that's all I've researched on. And we've identified a way forward for that. And we've identified potential apprentices, should we say, for that next phase of the project. So that's all I would suggest. You'll always meet somebody who'll try and knock you back, but just take it at face value that you're going to move forward regardless. It doesn't matter which path you take, as long as it's the right path for you and you enjoy it when you do it.
Absolutely. Thank you very much, Gary. And we've got Prof. Marabi. I just wanted to know if there's any comments from you, Adrian or Abdu.
What I would say as well, it's the same thing. Don't hold yourself and be open to everything, especially with the recent technologies that are getting out to the light, really. So AI has been here since the 90s when we've been looking at some of Fletcher's notes.
I actually started my PhD on using artificial intelligence to take the poop out of water by using the weather forecast, and that was 90s, yeah.
Electric cars have been here since what, the 60s, the 50s? It's
18 something, the first car was actually like,
so every piece of technology that exists and being highlighted and getting all the hype now did exist many years ago. But it's all about how the big companies are given it attention and how it is getting integrated with our daily life and the day-to-day jobs and how things are moving forward. So especially now with the AI hype that is almost similar to how the computers came around, to that same phase of everything moved from pen and paper to a PC. We are in this kind of phase now. So it all has to be about focus on what is going on and what is happening. Every day there is something new, and every day there is someone working on something, and it is changing different industries dramatically. So yeah, just keep your eyes open, be open to learn different sets of skills, because whatever you might have been doing now might vanish soon, and you might need to change and to go to learn something else and integrate with something else. So it's all about this, keep up with what's happening.
Absolutely. And I've just picked a couple of comments from our online attendees, just saying how wonderful this session is and I appreciate the experts. Thank you, guys. We'll get to all of the questions in a minute. And then just quickly, if Adrian, if you had anything to add before we conclude with Prof. Marabi, just in terms of staying resilient and job ready.
well, I think Sue said, treat every knockback as an opportunity, really, and it goes along with what Gary said, which is, stay curious, stay thinking about how you do things, question stuff. My dad called himself just an engineer, and he came home fuming one night saying that he'd interviewed an electrical engineer who apparently, in my father's words, knew about red electricity and blue electricity, but wasn't certain about where they changed. And my father simply could not understand the fact that this guy did not have a basic understanding of engineering as a whole. So where you apply this, how you do this. So regardless of what your specialism is, make sure you've got a good grounding in engineering as a subject so that you can actually question and say, hold on, that doesn't make sense.
Absolutely. So don't accept the status quo.
Yeah.
Be inquisitive. Prof. Marabi, just to close off on that, if you wouldn't mind, sir.
Well, they said it all. They ruined mine again because what I was going to say, continuous learning and updating your skills. That's the main thing, especially with sustainability, environmental sustainability in mind. To be fair, to be honest, Industrial Revolution, we've been doing this from very early stages, as because that's why we are we are here now. We have improved so much last 100 years. So this is nothing new. This is just another step, Industry 4, Industry 5, another step forwards. But we do need to keep environmental sustainability in mind at all times, and don't give up learning and keep updating our skills. That's the main thing, and everybody mentioned on that.
Thanks very much, and everybody's in agreement, which is wonderful. Thank you very much for that. Now we run out of a bit of time, so I'm going to just basically go over now to questions for our panelists, and I'd like to maybe start with everybody here. Are there any questions or any prickly questions that you want to find out? Some of you disagree with maybe that you want us to probe a bit further. Any questions from you here in attendance? Brilliant. Yes, please, Claire.
One question. Adrian, you mentioned degree apprenticeships. Do you plan to deliver this as a degree apprenticeship?
And so that is in discussions at the moment. I think it's very much needed as well. And so with our recognition sort of being this year, it is absolutely something we will be addressing. And that's a wonderful opportunity for us as well. So yeah, definitely. Anything else from everybody before we go on to our online attendees? We could always then just throw something in if something comes up as well. So thank you very much. So now I'd like to ask Barry, who's been looking after our online attendees, and everybody, please, we want to hear from you. We want to hear what you have to say. If you have any questions for our wonderful panelists. Barry, can you hear us still? Everything good there? I know it's about
all good, David. There's just a couple of questions here. Can I read them out?
Yep, let's take a couple questions, Barry. Absolutely, please. Yes, let's read them out.
Yeah, so I've got Brenda Munyai, mechanical engineer currently working as a production superintendent at a mechanical manufacturing company, and she wants to know what are the advancements I can do through AI to improve my role.
So what advancements can Brenda Munyai, what advancements can she add through AI to improve her role? Perhaps we can have two panelists sort of add some insights there. I guess perhaps what are the latest softwares maybe or processes that we can...
She might be asking about how could it be integrated with production. So production planning and knowing what should you make and when, quality control, find out where the issues would be.
Definitely
identify the main issues with your systems, with what you're making really. So yeah, I would say forecasting, planning, and quality.
Okay, how do we do that? What sort of do you have any techniques or any sort of programs?
Not programs specifically, but one of the key issues that you get is you create these the more sensors and the more data that you collect, the more information you become swamped in information. You have what some companies describe as data lakes. So you've got this huge lake of data, and how do we make sense of it? And this is where AI and machine learning can help. A lot of companies are now looking at, for instance, the torque wrenches that they use to bolt things together, transmit the data back to a central database that says, I've applied 25 Newton meters of torque here. What happens if it's only 23 Newton meters? What effect might that have on our warranty? Are we looking at something that's going to bounce back at us in a year's time and things like that? So they're starting to think about how they're going to use AI to actually predict what's our warranty cost going to look like, what's our quality status going to look like, what's that going to do to sales. And of course, you can use it in maintenance as well, in condition-based monitoring and things like that. Understanding trends. Is this machine actually going to last to the end of the shift? Is it going to last to the end of the month? Is there a problem coming up? Can we afford to to leave it until sort of the weekend to fix, or do we need to fix it now? And this is where AI is going to be quite handy and useful, I think.
So making sure we're staying absolutely on top of what software is available, what sort of processes we can adopt there. Brenda, I hope that is helpful. I've got another one there. I'm still studying for engineering with 25 years of experience as field such as HP mechanics. So which basic concept should I focus on as key factors for my new roles in the near future? I don't know if anybody is able to provide a few insights into that. Kia Filwe, I'm not sure. I think that we can possibly move to the next one for now. Hello, I'm an engineering student in Canada. So I have 3 years as a business engineer, but our business skills more than technical skills. My question, how can improve? Barry, can you open that chat a bit more, please? My skills in the technical field for your information are 2 master degree in my country, Algeria, instrumentation engineering. Okay, so you've got a qual, been doing more in the business side, but you want to go into technical. What would we do?
Possibly look at CPD, one-off small credit courses that have some sort of practical element into it or simulation element. And because you're employed by one, ask if there's anywhere that you can do some experience. Even I've known people in the past to do unpaid work experience just to get something on their CV to say that they've done some practical experience. But if it's instrumentation, then there should be a lot of things online, even instrumentation like sensor manufacturers might have small online courses that you can go through, or just training videos and things like that.
Absolutely.
Or preferably to enroll somewhere and get that certificate at the end to say that you've done it.
On that point, actually, just because it is very relevant, Engineering College of Technology, we have 3-month professional certificates of competency, which engineers in the workplace actually use for CPD, but also to either refresh or to be able to have a communication with automation engineers, or basically also we've got a lot of students that approach us and they do that professional certificate. There's no entry requirement, so that they can actually show that exactly we are actually getting something in that space. And it's not a long commitment like a degree when you especially have one. So definitely valid. I'm just conscious of time, and I think there's actually one more. So industry trends and insights. What are the most significant trends shaping the engineering industry? How can I prepare? What skills or knowledge areas do you think are most critical for engineers to focus on? So 2 questions there. Perhaps we can ask somebody, Gary, maybe, if you wouldn't mind me probing you, or anybody else.
Yeah, it's fine. I was just going to add one comment onto the last one who's got the tool making degree. What I would actually look at doing is look at it also from a simulation point of view, digital twin. It's exactly what Abdu and Adrian were referring to. If they can focus on the digital twin side, then you can actually correlate the tooling up to the business skills, because you can show a case study on how the company can save money by implementing new tooling. And you can use 3D printing to rapid prototype a tool, and you can actually show it at cost effect. The last question with the significant trends, I would actually, as I said, the guys have identified how AI can make a difference. And exactly like Adrian and Abdul said, it's a data lake. You can actually get too much information and you don't know what you're actually looking at. We've just had an incident where we were talking to Siemens, and I came to say Abdul before he came to you guys to say about this. Siemens actually couldn't provide us the answer with the software because they haven't caught up yet to where industry is in my eyes. They then rang me and asked for a meeting 3 weeks ago and asked me to explain how we fixed the problem. And I thought, hold on, guys, you're Siemens. You're asking me how I fixed the problem because we had to get it moved forward. So from the trends that's shaping us at the minute is we're looking at cost-effective engineering, preventative maintenance, planned using the sensors and everything within the controlled environment to tell us when the downtime is going to be. The machines we're currently building we're going to run them 20 hours a day, and we'll have a 4-hour downtime window where we will do predictive maintenance on them, which is driven by the actual sensor telling us what's going to need to be looked at. If we do that from an engineering point of view, we're keeping aware of the current scenarios and situations that we will face. Nobody knows what's around the corner, but if we can plan things out effectively using our skill sets and what the trends are, then we have at least a good idea of A, what's going to happen, and secondly, what we need to improve our own skills, because as you quite said it right at the very beginning, you never stop learning. You never stop learning. You learn every day. That's why we do what we do.
Absolutely. And I see Adrian listening to you intently and wants to add something.
Absolutely. I mean, Gary's quite right. But I think also another key trend to pay attention to is energy consumption and CO2. If we make more stuff and we continue making more stuff all around the world, CO2 is going to increase dramatically. So we have to make more stuff, but make it in a much more energy with much less energy. So we've got to pay attention to how much energy that we're using. So we're going to be data monitoring. We're going to be taking that information out. We're going to be using digital twins that predict how much energy is going to be used, and finding ways to manufacture parts in the most energy effective manner. And so that is going to be an important trend, I think, that's going to come, especially with the way climate change is going. But more importantly, I guess, for us poor cogs, it's going to be the financial people who are going to drive that, because energy costs and it's expensive. So we've got to use as little of it as we possibly can.
Absolutely, and a lot of very important sub things in there that you spoke about. Thing is not the right word, but I hope you know what I'm saying. We've got Barry, are there any more questions? I think there's one more comment there, and then there's just a last bit that I wanted to ask our panelists to close off on. Is there another comment there, Barry, if we can scroll down?
Yes.
Just show one comment. I wouldn't miss anybody out. Okay, great. So is anything else in the chat, Barry, before we conclude our panel discussion? Is anything else in the chat box anybody wanted to comment on from your perspective?
We've got something from Akim. Good day. With an urban design degree, how can industrial automation help me to be competitive in the evolving profession?
Urban design degree. Interesting. Anybody have sort of any comments on that by any chance? Urban design is probably niche, but you know, maybe also has to do with energy, use of electricity, traffic flow. I was actually, there's something interesting. It could be related to urban design, but there was something. I think it was with the 5G networks, the amount of energy that it you know. So when you're upgrading technologies and you're implementing it on a mass scale, you know, there's things that I don't even think about. You know, the amount of charge your cell phone takes with all the new technologies and how much electricity that is because the battery changes, which is fascinating. Probably moving a little bit away from the urban development, but
I would say design degrees, it's if you're designing things, as Gary started with his first answer, you have to really know how it is getting made. And this is where automation will come across. So if it is a very complicated, hard to make device, whatever it is that serves its purpose, so the automation system that's going to make it is going to be much more complicated. So from a design perspective, you have to really know how the manufacturing process are getting done or streamlined. So because when you know how manufacturing processes work, you're going to start to reflect that on your design abilities and your design considerations. And you can design anything futuristic and whatever it is, like how Kanye West designed a futuristic city a couple of years back in Africa and never kicked off, and it was all just nonsense. So that's the idea. A design, but can you make it or not? And this is where automation will tell you its capabilities. can automation serve that purpose and can it make it affordable or not? We've seen all the prototypes for everything that's possible, but manufacturing and mass production is different from prototyping. Like how Elon Musk is trying to mass produce rockets. And this is totally different from just making spaceships by NASA or by whatever agency. So mass production is a totally different process, which requires totally different abilities, design, and how can this happen? So they all link together and they all reflect on each other. It's all about knowing what are the abilities of automation so you can reflect that on when you design something.
Absolutely, because if you're not careful, you can go bankrupt, because if you sell it and you can't make it deliver on time, huge implications.
And we applied some of those tools and techniques into healthcare as well. A colleague and I were called upon to help the NHS design one of the COVID labs during the COVID crisis. And the NHS know about testing and laboratories, but they maybe do 1,000 tests a day, different things. So it's more like a cottage industry. And what they wanted to do was 80,000 COVID tests a day, keep 600 workers over 3 shifts safe. And they really didn't know how to do it. And we actually sort of helped them, and we applied lean mass manufacturing technologies and techniques to them, and help them to understand this is where you use barcoding, this is where you use this is where you use simple color coding. Yeah, so if you see something in an orange bin, don't touch it because that's still live. If you see it in a white bin, it's okay, it's been cleaned. And one-way systems and so we put the whole thing in, and by and large it worked pretty well.
Incredible. Yeah, brilliant. And just because, just in terms of the last one there, thanks very much, Adrian. Prof. Marabi, just a last comment from you before we go to Sue.
Well, just to share, a little bit of my experience by automation, it's automation helps in mass production, helps to reduce energy consumption per part. This is what we've actually experienced a few years ago through the research work that we did with some companies, 2 different companies, one batch production, one automated production, both producing the same goods, but the one with automation, the rate of production was much higher and the energy per part was much lower. So that could be one of the very important parameters in terms of energy saving that Adrian was mentioning by automation. That's why I just want to share that.
Brilliant. Thank you very much, Prof. And one last comment from Sue.
It was just going back to the urban design that
Urban design.
I can relate to is building management systems are full of instrumentation.
Yeah.
And they do have some automation now where you automatically open windows, blinds, shades, tilt solar panels and things like that. So maybe that's one way that the person who asked the question could think of trying to get into instrumentation.
Yep.
Yeah, and that can be used in shopping malls and, big arenas and things like that.
Absolutely. And I actually wanted to mention, we've also got a professional certificate in building information management. And that's very relevant too. Thank you very much. Just in terms of the questions, I just wanted to check, is anything else there? I'm a mechanical technician. I wanted to know how one can transcend in growth after gaining over 10 years of experience. And I guess the panel's already perhaps touched on that. Stay curious and look for opportunities to grow yourself. Put your hand up for different projects. Perhaps also maybe if you're looking to move into a different area, perhaps, professional certificate in a different area to gain some knowledge. If you have a Bachelor of Mechanical, a congruent degree, perhaps in a master's could be something you're looking for. Experience is naturally the most important thing there. I guess it's just basically looking for opportunities, putting your hand up, and then putting yourself out there. I hope that's okay. Pascal Filbert says, comment, with the rapid advancement of technology driven by increasing computing power, it is essential for engineers to engage in continuous learning. Participants in workshops and seminars participating in seminars and workshops allow them to stay current with the latest developments. Additionally, attending technology exhibitions and trade fairs will further enhance the awareness of emerging trends and innovations. Absolutely, that's what we're saying. Brilliant. Thank you very much, Pasha. I wish you were here as well. Perhaps let Barry know where you are and you can join one of our panels. It'll be wonderful. And we've got a great session. So I just wanted to say thanks for all the questions. Thank you very much. And then any other comments from you guys? Okay, brilliant. Just to conclude now, and again, we're very fortunate to have all of you, all of the experts here. And so I hope you don't mind, but I've just got one more thing to ask of you, just for the benefit of all of our attendees online and here. And forgive me if I'm going back to it again. And so I might go, if that's all right, from Prof. Marabi to Richard to Gary, and then our in-person panelists here. Just so, Prof. Marabi, nobody can get your comment first. So I just wanted to make sure I can ask you first there. Thank you very much. You can just give one sentence. And I know it's tricky because there's so much advice we can give. But just one sentence, your top piece of advice for being future ready 2026 and beyond.
Now you ask me first.
Yes.
Well, it's 2026. Engineers, based on my research, engineers, well, not engineers, everybody, the whole world should behave in a sustainable way, sustainable manner towards environmental sustainability, specifically engineers, because no matter what politicians and economists do, it's the job of engineers who actually make things more sustainable and environmentally friendly. So thinking sustainability at all times, performance and sustainability, not just performance.
Thank you, sir. And Richard, thank you very much. And Richard, over to you. One sentence. How do we stay future ready? If you can just unmute yourself there, Mr. Scott, if you don't mind, sir. I do that every time I have a Teams meeting, so it happens, unfortunately. Thank you very much.
Here we go. All right, okay. You need to be aware of industry trends. It's varying as time passes. Industry trends change. So, industry trends, their automation needs change as well. And then the available solutions, let's say the commercially off-the-shelf solutions that you might find from a manufacturer are also evolving. So just keep tabs on it all. Be aware of how things are moving so you don't get caught out. Don't fall behind. That's the best advice I could give to anybody, I think.
Don't fall behind. And I'd also like to encourage you to subscribe to our newsletters for Engineering College of Technology. That's what we want to do. We want to keep you abreast, and we write a lot of articles in the marketing department to do exactly that. So we'll help you do that. Gary, just a sentence from you. That's an awesome background there. Thank you. That's brilliant.
That's actually the machine I'm building. And the one thing I'm going to say is, and it's exactly what Hamid was on about and Richard, try and use a local supply chain. So if you're going to build something and going to make something, try and use the local supply base, grassroots machinist companies, suppliers and everything, because if you can go out and see them and you can actually talk to them face to face, it makes a hell of a difference. Now, this big thing I'm building behind, which weighs about 4 tons, is all being done within 15 miles of here. So everything's come local. And when that goes into full production, which is going to be in Sunderland, just literally over the bankside from Sunderland University, we'll be bringing the apprentices in to do the design work and the build on this, and all of those will be coming from the local area. And we'll be encouraging to support them into degree apprenticeships. So that was the only thing I would say, hence why I took the backdrop off so you could see what we're doing, because literally everything's been made on the doorstep.
Wonderful. And we should have asked you to take it off in the beginning because it's really fascinating. Thank you. And I guess relationships are important because you can achieve something through trust as opposed to just demanding, right?
Yeah,
I think you get more done
exactly.
if you actually have a relationship.
All the guys, exactly. The guys who've done the machining are literally 15 minutes up the road from me. The guys who've done the fabrication, 20 minutes that way down towards Teesside, everything's been made local. So when we powered it up, we can actually get everybody around and say, right, we do the analysis, do the review, let's put it into full production. Like Abdu said, that's a prototype. Once we actually put it into full production, then that's when it scales up.
Fantastic. Thank you very much. And I just wanted to move to our panelists to conclude. Since I had you last, I hope you don't mind. Actually, you know what, ladies first, apologies. So if you wouldn't mind, if you can do a sentence for us, top piece of advice, why don't you?
Agree with what everybody else said, but also your personal career, look at the opportunities, not necessarily for the best salary or whatever. It's what's going to give you the skills to take you ahead, because it's quite easy as an engineer to sit in a drawing office designing machines for 20, 30 years and never actually getting the chance to go out and find out what the new technologies are about. You just sit, not on machines or whatever, go out there and take risks with your career.
Absolutely. And that's something I've always done as well. And I think that's, if you're always taking risks, you'll never stagnate. You might have some trouble, but I guess that builds resilience, right?
Yeah.
Abdu, if you don't mind adding to that, one sentence or two, what's your best advice?
I would say be open to change, be open to technology. A lot of it is going to happen in the next few years. A lot of it is going to change many, many industries. Learn different things, different skills, accept change. From my point of industrial automation, if you did learn about the basics of industrial automation, well, congratulations, you made it to the 60s. It came around. You have to know what it can be used for and how could it be modernized, and what the different technologies that gets built on top of it can do and can make.
Thank you very much. And certainly last but definitely not least, Eugene, what would you tell our engineers?
I think adding to what all the other excellent panelists have said is keep abreast of new technology, stay curious, ask yourself, how can I use this? What can I use it for? And keep doing that. And finally, I would say that if you're just starting in your engineering career, it's a fantastic career to have, but always make sure that you're doing something which interests you and you're not just, as Sue said, sitting in the drawing office, working on a CAD screen and dying slowly.
Exactly.
Yeah.
Being bored to death and keeping the days away.
Unless you like CAD.
Yeah, unless you like CAD. If you like CAD, absolutely fine.
No offense if there's any CAD lovers out there. Thank you very much, but absolutely wonderful advice.
Well, Gary loves CAD.
Oh, sorry, Gary.
Yeah. Gary then goes out and makes the things that he designs. He's doing the thing that he loves. Yeah.
The best thing, Adrian, the best thing about this, mate, it's actually going to be used to generate electricity. And it's what I showed you a couple of months back when I caught up with you at Sunderland. So that's the first of another 96 we've got to build by March.
Oh, wow. Best of luck. And please keep us updated here at Engineering College of Technology. In fact, we might reach out to you just to do a bit of an article, if that's okay. It'd be wonderful. If that's all right. Thank you very much.
That's yeah, it's fine. I mean, that'll actually this here, we could actually take the university off grid with one machine setup. And the system itself will generate 1.2 megawatts an hour of electricity.
Fantastic. We'll definitely be in touch, Gary. Thank you. Thanks very much for that. I wanted to thank you for the time. We've gone over a little bit, but I love these events. We do them all over the world. And I'm fortunate now because I'm myself, not an engineer, but I understand what everybody's talking about and how it works. And I think that's just a testament to the quality of the panelists. And I'd just like to say, just to finish up, with Engineering College of Technology, these are the types of things we embrace. We want to create relevant, practical engineers. And a lot of the people that do programs with us and do degrees with us, certainly we invite them to events as well. And what we always find out is that engineers we produce are and this is feedback from employers, that they are naturally inquisitive and they do not take no for an answer. They use the initiative, and I think that is exactly what we want, exactly what we need. So, and just another point as well for the Institute of Engineering and Technology, where we are located today. We're a bit late, so everybody's gone home, but we wanted to say thank you to them. We appreciate the support. If anybody online and anybody's there in Stevenage, London, or Birmingham, pop out to the facilities. They're amazing. We really do appreciate their collaboration support. Last, now equally important, thank you very much for the online attendees and everybody here for your time. And I really wanted to say thank you. It's been a pleasure and a privilege to have Prof. Marabi, Richard, Gary, Sue, Adrian, and Abdu. It's been a wonderful pleasure to have you here. We really appreciate that. So if you have any information that you need about Engineering College of Technology based in Stevenage, or perhaps one of our courses, sister college, come talk to us online, contact us. Barry's going to drop some information in there. There's a certificate of attendance. If you would like to scan that you'll get that, everybody that's here. And also online attendees, you'll get your certificate of attendance and the slides that we have. And so thank you very much. And I hope you have a wonderful day wherever you are in the world. I wish I could actually see everybody there so I could figure out how to, which country from, and get a couple of words there, local words that I can learn. I love to do that. So thank you very much, and travel safely. Thank you. Take care. Thank you.
Thank you, everybody. Thank you. Bye-bye.
So the team. Yeah. Thank you very much.
Folks.
Take care.
All the best.
Thank you. And thanks.